Okay, guys, welcome to section 3.1, which is actually going to be our introduction to data collection and just the chapter in general is how do we collect data. And that might not seem like a very important thing initially. You're just like, okay, what's data? And I'm just maybe taking a survey or a poll or asking people questions, whatever it might be. But the way people do it is actually really important if we plan to trust the results. And I think for you guys, a lot of you, especially with how relevant the internet is and websites and social media, a lot of the polls, the information that we see really needs to be put into question. I know for example, this chapter, when I first was teaching statistics, certainly made me start to question often, okay, where's this information coming from? How was that data collected? Do I even trust the results? Those are questions I never really asked myself before, but it certainly has made me more informed. And I hope that it does the same thing for you because, like I said, with as much as you guys are able to see now on your phones and iPads and TVs and computers, what you trust and what you don't trust is super important. And I really, really, really do think from an objective standpoint, right, mathematically, statistically, that how that data is collected and then how that data is used is super, super, super important for us. All right, so let's talk about some of the initial things on how we collect data. First off, we need to always ask a question, and let me change my color here. It's white, sorry. A valid statistical question is based on data that vary, right? We want things to vary, okay? So that is, the answer to a question won't be the same in each observation. Okay, it won't be the same in each observation at each time an observation is recorded, pardon me. So in other words, like, I'm going to ask a question and not everybody's going to give me the same answer, right? And that usually is a sign of a valid statistical question. We never want to phrase a question in a way to like trick people, even though that happens, or try to get one solid answer out of everybody. It just doesn't make sense. So we ask questions and we want to clarify. What we want to do is we want to clarify the research problem and ask one or more valid statistical questions. After we ask that question, we'll collect the data. Okay, and to collect the data, what we'll do is we'll design some way to carry out an appropriate plan to collect that data. And we will certainly spend a decent amount of this chapter learning how to design those. Once we have that, we'll analyze the data. And we'll usually use like some sort of graph, so a graphical and numerical method, so maybe means, medians. We'll even talk about proportions, and then we'll interpret, right? Of course, after we collect, we review, and we see the data. We, of course, want to interpret the results, and we'll draw conclusions based on the data analysis. All right, so let's look at a couple things. So whether or not questions are valid. All right, so let's determine if each of the following is a valid statistical question, and then, of course, we'll justify why or why not. So how many days did students at your school play video games last week? Okay. Really what we're basing this off of is the way the question's asked, would we see answers vary? And in this case, yeah. I mean, there's nothing really in here that's trying to trick you or trying to get you to answer one way. We would simply answer numbers based off how many hours people played. And so we would say, hey, this one is valid. We would see different answers. Okay, valid. And we say the number of hours. I'll just kind of explain. The number of hours a person or a student plays video games would vary. And again, simply because it varies means that it's a good question. Yeah. All right, let's look at another one. Which gender is more likely to choose vanilla over chocolate ice cream? So you think about this, okay, would we get different answers? Yeah, some people would say male, some would say female. So I think, yeah, this is valid also. It seems like our answers would vary from person to person. And we'll just put, same answers above. Same reason. Let's say, yeah, same reason as above. Sorry, I got that little line in there as I was moving across. There we go. All right, same reason as above. Okay. How many people in the United States were convicted of violent crimes last year? So you think, okay, last year, how many people? And then you think to yourself, wait a second, would we have answers that sort of vary there? And the answer here is no. This is sort of a singular question, right? We'll have one answer to this question. The answer would be the number of people who convicted violent crimes last year. And there's really no other sort of answer to it. So this is not valid. This is not something we would kind of dive into in a statistical sense. This is just a single number. Nothing else to it. Okay, so that's a little bit about what a good question looks like and then what a bad question looks like, all right? All right, so suppose we wanted to find out what percent of drivers in the United States text while driving. To answer this question, right, we will survey 16 to 20-year-olds who live in the United States. Okay, so when we ask a question, like let's say we want to dive into this texting and driving sort of thing, we would essentially say, okay, how many people are we going to ask? Now, ideally, we would like to ask all the 16 to 20-year-olds. Really, well, it says in the United States, so I guess just within the United States. Really, we'd like to ask all the 16 to 20-year-olds in the United States, do you text and drive, right? And if we do that, when we ask everybody, we call that a census, okay? But here's the issue. A census is extremely hard to do. In fact, if you guys think about it, if you're familiar with the census that we take it once every 10 years. The reason we do that is because it takes so much time and money and just effort to get the data together, to get the process, to plan it out. How are we going to deliver all these things this year? And then how do we take that data and turn it around and then analyze it and come up with conclusions? And so it's a full 10-year process. That's a lot of time to collect data, especially if we're trying to get some results that are relevant. I mean, who knows? In 10 years from now, texting and driving, if we have, let's say, everybody has self-driving cars, let's just get real crazy, texting and driving would be obsolete at that point. Now, this data that we collected wouldn't even be valid anymore. So people are looking for very quick turnaround times. In a sense, it just isn't realistic. It would take too much time. It would cost too much money. So instead, what we do is we put the question to a sample of people. Okay, a sample of people that are chosen to represent the entire population of young drivers. So in other words, instead of collecting all 16 to 20-year-olds and asking them the question, we'll take maybe 100 people that age, and we hope that those 100 people are representative of the entire population so that whatever result we find would typically be the result. Now, that should be an intimidating thing, a task that says, hey, you can only talk to 100 of these 16 to 20-year-old drivers, but those 100 that you choose have to represent the entire population. They have to be, some have to text a lot, some have to text a little, some have to text not at all, some have to text in, the medium amount. And you have to get a little bit of everybody in that sample. Now, we have ways to collect data that will allow us to have it be representative, but yeah, it's a kind of a daunting task. Okay. So the population, let's kind of define a couple more vocabulary words. The population in a statistical study is the entire group of individuals of that information. So in the example above, our population would be all 16 to 20-year-olds drivers in the United States, not around the world. Sometimes people think population means everybody everywhere, but it's the entire group within that set of people that we're asking about. So since we only asked about teenagers in the United States, our population is all teenage drivers in the United States. A census, like we said, collects data from all of our people in the population, the whole population, and a sample is a subset of individuals from that population. So in other words, instead of contacting the whole population, we'll just take a sample and hope that our results match what we would have found otherwise. All right, so identify the population and the sample in the following. So let's look at this. Wildlife biologist in Alaska tranquilizes 42 grizzly bears in the state and records their weights and then releases them afterwards. So we think about our sample. Our sample is actually easier to identify here. It's going to be the 42 grizzlies in Alaska. And notice how specific I'm being. You do want to be very specific about where they're found. In other words, you're just kind of copy and pasting the information from above, but you don't want to just say like 42 grizzlies or 42, okay? Now, the population isn't as obvious here, but we are talking about grizzly bears in Alaska. And so when it comes to our population then, we'll say that our population is all grizzly bears in Alaska. Not in the world, not in the country, right? We're not asking about those. It's just those grizzly bears in Alaska. And so there's our population, and then there's our sample. Okay, a teenager selects 15 Beyonce songs and counts the number of words in each song. Okay, so our sample, kind of easy to identify, is the 15 Beyonce songs. Now, our population, if you think about it, okay, we're talking about Beyonce, we're talking about her songs, so our population then would be all Beyonce songs. And there's our population, and there is our sample. Nice. Okay, so since we're going to focus mainly on samples, because it's pretty impossible to in a lot of cases, contact or get information on the entire population, right? We'll use surveys and other different methods to collect that data. So a sample survey, which is a pretty common way to collect data on a sample, usually aims to gather information about the population without disturbing the population in the process. Sorry. Okay, sample surveys are one kind of what we call an observational study. So kind of from a visual standpoint, what we'll do here is imagine this blue box is our entire population. It's everybody that we're considering. We obviously can't collect data on it, so we just take a subset of that population. We call that our sample. So maybe it's like 100 people out of the population, and we'll collect data from a representative sample to do that. And right now we're saying, hey, this sample survey is a great way to do that. Now, observational studies are pretty kind of like open-ended. They're very subjective in the sense, I mean, yeah, a survey, you answer a couple questions, but I've also seen observational studies where you just literally observe people's actions or behaviors, things like that, and you kind of draw conclusions based off that. They're not as sort of concrete as some people would like them to be. So in contrast to observational studies, to get a little bit more of a definitive answer, some people like to use the other type of method, which are experiments, right? And they don't just observe individuals or ask them questions. They actively impose some sort of treatment, okay, to measure a response. We see this a lot with medications. Right now, COVID-19 vaccine is like the big topic at the moment. It is an experiment. They will run trials. They have taken a subset of the population that they think is representative of the entire population. Although they're using volunteers at the moment, so there's a little bit of an issue there. For me personally, when it comes to the COVID-19 vaccine, one of the first things when they do sort of release this data and look at it is I do want to know how they chose the people that took the vaccine in the first initial trials. Because, like, for example, let me give you guys an issue or kind of an example really quickly with these experiments. What if everybody who volunteered to take the COVID-19 vaccine was like a healthy 20-year-old person? They took the vaccine, their body handled it fine, everything was good, but what if we didn't have an elderly person in that volunteer group? What if we didn't have a sick person with an immunodeficient disorder in that group? So we don't know how the vaccine works for them. And then all of a sudden we release this to the entire population because it worked for our sample, and we're in a little bit of trouble. So I'm very curious. So these experiments impose these treatments on them. And again, going back, that's why it's so important for us to pick a correct sample, okay, because of those adverse side effects that we could have. Okay, so let's kind of make a couple distinctions between an observation and an experiment. So an observational study, we can kind of go over here in this box real quick. observes individuals and measures a variable of interest. Like, for example, what is a high school student's morning routine? Do they eat breakfast? Do they get dressed? What order they? And you could just kind of have them log, what they did in the morning. And that would sort of be kind of my variable of interest is their morning routine, but does not attempt to influence the responses. I'm not doing anything. I'm just asking a very simple question. I'm kind of sitting back. I'm observing, or I'm having you kind of report your results of maybe, like I said, you journal or you log about what happened that morning, so on and so forth. An experiment, though, on the other hand, deliberately imposes a treatment on an individual and measures their response. So if we go back to the routine thing then, and I say, well, the first thing you must do is you must eat breakfast every morning. And for some people, that's not the first thing that they would do. But if I impose that treatment, I could see how people respond to it. Does it throw their day off? Does it actually make their day more productive? So on and so forth. Okay. So the distinction between then these observational studies and this experiment is one of the most important ideas in statistics. Okay. So the goal of an observational study, can be to describe some group or situation. We might compare groups, or to examine, the relationship between variables. Okay. The purpose of an experiment is to determine whether or not the treatment actually causes. There's like a cause thing. I'm going to star this because this is going to be a big focal point for us coming up in later chapters, whether it causes something in the response. Okay. An observational study, even one based on a random sample, and I'll talk about this, this will also be a big focal point this chapter, random sampling, is a poor way to gauge the effect that changes in one variable has on another variable. In other words, you're never going to draw a causal type of relationship from an observational study. You're just not. Like, I can't look and say that this caused this to happen through an observational study where I just observe or whatever. I would have to run an experiment. Okay, so when the goal is to understand cause and effect, experiments are the only source of fully convincing data, okay? Why do we choose then not to do experiments why wouldn't we do experiments every single time? Observational studies do have their place, but they also are a little bit easier to run at the same time. So, you don't have to actually impose treatments, which can cost time and money and things like that. You can just kind of have people be a part of the study. So a lot of times people will use an observational study and attempt to sort of state, hey, this is what I saw. I'm not saying this caused this, but this is what I saw, and I think that I believe that this, these two things have a relationship. But until you run an experiment, you cannot say one causes the other. All right, so let's just determine whether or not each of these has the following settings: describe an observational study or an experiment, and explain your reasoning. Okay, so 64-year-old children were randomly divided into three groups. One group was shown a fast-paced cartoon, one group was shown an educational cartoon, and one group was given art supplies and instructed to draw pictures. Afterwards, the 4-year-olds who watched the fast-paced cartoon scored significantly worse than the other two groups on tests that measured the ability to make decisions. Okay, so before we talk about that one, even though you might have an idea of what that one is, let's read the second one. 100 teenagers between the ages of 16 to 18 were surveyed. The teens asked whether, as young children, they watched fast-paced cartoons more often than, less than, or about equally as often as educational cartoons. They were also asked to reveal their GPA. The teens who watched fast-paced cartoons more often than educational cartoons had lower GPA than teens from the other two groups on average. So, a couple things. One, notice in this second one, they use the word surveyed. You'll notice that they surveyed them, asking them questions. This is what makes this an observational study. I think the main reason this makes this sort of an observational study. They didn't actually impose this treatment. They just sort of asked them some follow-up. And yes, they're sort of drawing conclusions based off that, but they're not really necessarily saying that one's causing the other. They just say there's a link between them, the GPA and the type of cartoons they watch. However, on the top, they were randomly divided into 3 groups, and then they were shown different types of cartoons. That's what makes this one an experiment. Okay. And in this case, they can actually make decisions and say, hey, these fast-paced cartoons are causing, this effect in their GPA or whatever it might be. Okay, so that's a little bit about experiments and observational studies, the setup for Chapter 3. At this point, I would ask that you have a homework assignment that would be due on Thursday morning at 8 a.m. on this section. If you're watching this on Monday, you obviously need to also prep for the test tomorrow. If you're watching this on Tuesday, then all you need to do is go get the 3.1 homework finished. And again, that's due Thursday at 8 a.m. If you have any questions, let me know. I will see you all later. Thanks.